Hello and welcome to this lesson for CPI 111. In this lesson we're going to create a maze game, and ultimately we're going to be making the game that's in Chapter 7 of the course textbook, that koala game. But the koala game has a lot of visual stuff going on. So before we get into the koala game, I want to first show you a simplified version of a maze game that will let us focus just in on the mechanics and the way that GameMaker is doing things behind the scenes in order to help you develop a maze game quickly and relatively simply. So let me show you a finished version of a very basic maze game that has the same core mechanics as the koala game to show you where we're heading in this initial demo. So here we're looking at a maze that's pieced together from a series of wall tiles and then leaves an open corridor. We've got an exit tile, and we've got a button that needs to be pressed in order to open up this door. And this section here that looks like a single red bar, actually this is 3 separate players in our maze. Each player consists of a square, red square object. If I use the arrow keys on my keyboard and I push one down, you'll see that one of the red players moves down, and it continues all the way down and then lines up perfectly with the next slot in the maze. And if I press again, now 2 of them move down and line up just so. Now 3 of them move down. And if I continue to hold down the arrow keys, you'll see that they move down and then come to a stop. If I use my right arrow key here, then one of them will switch. If I do down, that will come down with me. And you can begin to get a sense of how the players move. Something that's really key for you to notice is that even if I just barely press the down arrow key, the player objects don't move just 1 pixel or 4 pixels or whatever. They will continue even if I release the arrow key until they line up perfectly in the grid that I've laid out inside my maze. And this is really a key piece of action that we need to set up in order for maze games to work well inside GameMaker. So let me show you how that's set up now. So now we've got an early version that doesn't have a player object in it. Doesn't really matter the stuff we have in here, but here we can see briefly player, wall, exit, button, and door sprites. And then we've already created some of the objects that allow us to have our initial maze. We have a wall object, and all the wall object is just no code, no events, no actions, just a simple wall sprite. It's visible and it's solid. We did something similar in our very first assignment with the wall that went around our room. We just created a wall object that was solid. We have an event object that isn't even solid. It actually has absolutely nothing going on. It just has a sprite associated with it. And the same with our button object. Just visible but not solid. And our door object simply visible but not solid. So let's create our player object, and we'll start getting at that code that's going to allow it to work properly inside the grid of our room. One thing to notice as we're setting this up, I've got the room open right here, and you'll notice that I've got the snap X set to 40 and the snap Y set to 40. If I come over to my sprites, you'll notice that my player sprite has a width and height of 40. So it matches the Snap 2 grid, and we're using precise collision checking. These are important settings to notice as we set up our game. Similarly, our wall sprites are all 40 by 40, as is our door. Okay, let's go and create our player object. We'll give it our little red square for the sprite. Now let's create some events and actions to help it work properly. We're going to have a step event, and we're going to use begin step so that all of the actions will occur before anything is drawn on the screen initially for this step. For our actions to go with this begin step, we're going to use a new action that we've not used before, one that's extremely useful for maze-based games. And it's going to be under the question section. There's a little, one of the question actions is called check grid. And what this is going to do is it's going to tell us whether or not our player object is aligned with the grid that we are setting up in our room. And remember, we've got a 40 by 40 snap to grid, so we're going to be checking to see if our player object is aligned with that 40 to 40 grid. Then if it is, we're going to, well, we're really only going to do one action in this sample game, but I'm still going to use start and end blocks just because it's a good habit, because when you start making your own games, you're almost always going to be having multiple actions occurring. It's easier to keep track of what's going on. So I'll use a start block, and then I'm going to use a start moving in a direction, and I'm going to say, let's see, I'm going to say stop and 0. Now that seems odd. We have the idea that we're going to have our player moving when the player presses one of the arrow keys up, down, left, or right. But here we're beginning the step for the object player by telling it to stop. Now, this makes sense if you think about how the game is going to work. Right now, if we have that event with essentially a stop, move, fixed action, it means that if the player isn't pressing one of the arrow keys that we're about to set up in a minute, then that player object will always stop. As soon as the player lets up on one of the arrow keys, then the player object is going to stop, and that's what we're using here. It's a better way of doing the no key action that we tried in a previous assignment. This one is a little more robust. And I'll add an end of block. I'm going to add a collision event next, and it's going to be the event when the player collides with the exit button. It means that they've completed the level. When we have a game that's going to have multiple rooms, then ultimately we're going to have it set up so that the player could then go on to the next room. But for now, we'll simply destroy the instance. And we're destroying the instance of the player, so it's going to look as if the player has disappeared into the exit. And we'll add a collision for when they collide with the button. This time we're going to have a couple of instance destroy actions. One is we're going to destroy the player, we're going to destroy the button, not the player. That's what we want to have happen, is make it look as if the player's run into that button and the button has disappeared. And we're going to have another destroy instance. And it's going to be the door, so that when the player collides with the door, it will destroy the button and it will remove the door from the maze. Next, we're going to add a keyboard event left, and here's where the real action is. I'm going to come down to our control to the question section and do another check grid. And this time we're going to do sort of the opposite of what we did in the begin step. Remember, the begin step we checked to see if the player was aligned with the grid, and if they were, then we stopped the player object from moving. This time we're going to say if the player is not aligned with a 40 by 40 grid, choosing not, then we're going to exit out of the event. So if the player presses the left arrow on the keyboard, but their object player is not aligned in that 40 by 40 grid, which can happen, right? As they press the key, there'll be moments when they're sort of in between one grid and the next grid. So when that happens, we're just going to exit out and not have any action take place when they click the left arrow key on their keyboard. So that's what we've got here. Exit this event. That's from the other section on the Control tab. All right, now we're going to do another check. This one is going to be a check object. And we're going to check the wall object. And we're going to see if there's a wall to the left of us, to the left of the player object, 40 pixels. Makes sense. We've set up the 40 pixel grid, so we're going to look all the way. We're not going to look right next to it, but we're going to look 40 pixels over, because that's where we would be moving next. Using relative, so 40 pixels from where the player object is at a given moment. And we're going to see if there is not an object there. Let's walk through all of that. So the player clicks the left arrow key. First we check if they're lined up with the grid, and if they're not, we exit. So that if they are lined up with the grid, now we're going to check to see if there is an open space, essentially, by saying we're going to check if there is not a wall to the left of them, 40 spaces. Then they'll be able to move. So that's the check. We'll do another start block. And another move. This time, because the space is available, there's no wall there, we're going to allow them to move to the left at a speed of 5. And we'll end our block. Now we're going to come back over here on the Control tab, and we need to know what to do if there is a wall to the left of them. This one's checking if there isn't one there. Well, what if there is one? So we're going to use an else statement. Put in another start block. Put in another move fixed. This time we're going to stop our player object. Make sure to set the speed to 0. And put another close block. Or end a block. Okay. So we've got the left button all set up. Now we're going to set up the right key, the up key, and the down key. And they're going to be set up in very similar ways. In fact, what you can do is add an event, and let's add a keyboard right event. And if you come back to the keyboard left event and holding down the shift key, select all of the actions and then right click on them, you can choose copy. And then come down and click on the right keyboard event, click in the action pane, and click in paste. A lot of it is going to be the same events, we just need to modify the actions. So let's start by looking at this first wall check. Last time when we were going left, we checked if there was something 40 pixels to the left by saying minus 40. Now we're going to check 40 pixels to the right by using a regular 40 and leave everything else the same. Similarly, last time we set it up so they could go to the left 5. This time we'll set it up so they can go to the right 5. And then the rest of it is all the same, right? If there isn't an open space, we're going to make sure that they stop. Let's add another event. Keyboard up. I can paste in again. But now our object check is going to be different yet again. We're still checking object wall, but this time we're checking right where we are horizontally, but we need to check above the player object vertically which is going to be a minus 40y. Minus in numbers on y is going up, and checking relative and not. Then we'll choose the up arrow and a speed of 5, and the rest all stays the same. One last keyboard event, this time down. Pasting it in, doing our object check, setting the x to 0 and the y to 40. It's a positive number. We're going down relative and checking if there's no wall there. If that's the case, then we'll go down 5. And everything else is the same. Now there's one thing more that we need to do with our player object. When we looked at the game at the beginning, you saw that if I pressed one of the arrow keys, like the down key, only the bottommost player of the 3 players actually moved. The other 2 didn't. And the reason that is the first and the second player, the topmost player and then the one that was stuck in the middle on the line of 3, they had all of the code here, and they checked, and what they were checking for was to see whether or not there was a wall object below them when I pressed the down key, and it found one so that it wouldn't allow them to move. Now, how could it find that there was a wall object below them when there was no wall object below them? All there was another player object. Here's where we can again make use of parenting, the thing that we studied in our recent lesson. If we have a parent to this player object that is an wall object, then the collisions for our player will all make use of that wall object, and so it will treat each of the instances of a player object as sort of a special case of a wall. Logically, it's a little bizarre, but by setting it up that way, we can make it work the way we like. So under the parent section for our player object, I'm choosing the wall object as the parent. And saying OK. Well, that's pretty much it in terms of setting things up. But one more thing we need to have. We're not really going to need it for this game in particular, but when you go in and make your koala game, you're going to need it. So I'll create it now just as a demo. We need a controller object. We're almost always going to need these in any game to manage everything that's going on in the game and to keep track of variables and so on. So in our object controller, we've got no sprite associated with it, and it's going to have just a single event, which is going to be a step event. So it's going to just keep checking what's going on in the game. And what it's going to check for us is it's going to check how many player objects there are in the room. So if you think about how we want the game to work, in our maze game, we want it so that the player has to get all of the player objects out of the room. And when they get all of them out of the room, then the level is 1, and then they can move on to the next room. So we're going to say if there are no player objects left, so if it's equal to 0, then we're going to go to the next room. Now right now this is going to give us an error because there is no next room. There's only one room. But when we get into making the koala game and you get into your next assignment, you're going to have to create 3 rooms, 3 levels of the koala game. And so you'll need to make use of this controller object. Alright, I'm going to save what I've got so far. And to try it out, I'm going to place my player object. I'll stick 3 of them out here. One right here, one right here, one right here, just to test it just the way it worked in the example I showed earlier. So let's see if it's working. Right, here's our maze again. I press the down key, they all start moving. You'll notice that they continue to move even after I release the key until they come down and fit into our little grid. They come down and hit the door, they can't move anymore because there's an object down there. That door object is also set up with its parent being a wall. That's why it's unable to move. And if I come down and hit the button, then the wall object disappears, and I'm able to escape the room. Okay. So that's it for this video. In the next lesson, next part of this lesson, I'll get in and we'll start working with the real koala game.